identities. It is used the double angle identities to derive the half angle identities. Like the double angle identities, half angle identities will allow to find certain exact values of trigonometric functions and trigonometric identities. Start by writing the second and third forms of the cosine double angle identity to obtain identities for the square of the sine and cosine functions, sine squared x and cos squared x. So, write the second form of the cosine double angle identity. So, we have cos 2a is equal to 1 minus 2 sine squared a. Then isolate the 2 sine squared a term on one side of the equation. So we have 2 sine squared a is equal to 1 minus cos 2a. Then divide both sides by 2. So we have sine squared a is equal to 1 minus cos 2a over 2. Then write the third form of the cosine double angle identity. So we have cos 2a is equal to 2 cos squared a minus 1. Then, isolate the 2 cos squared a term on one side of the equation. So we have 2 cos squared a is equal to cos 2a plus 1. Then, divide both sides by 2. So we have cos squared a is equal to 1 plus cos 2a over 2. So taking the quotient of this, tan squared a is equal to sine squared a over cos squared a. So we have sine squared a is equal to 1 minus cos 2a over 2. Then, our cos squared a is equal to 1 plus cos 2a over 2. So, our tangent squared a is equal to sine. Our tangent is equal to sine over cos. So, we have the value of sine squared a is equal to 1 minus cos 2a over 2. Then, substitute also the value of cos squared a, which is 1 plus cos 2a over 2. So, we have 1 minus cos 2a over 2 multiplied to the reciprocal of cos, or the denominator, which is 1 plus cos 2a over 2. So, we have 2 over 1 plus cos 2a. So, cancel the 2. Then, we have tan squared a is equal to 1 minus cos 2a over 1 plus cos 2a. Then for this side, half angle identity starts with a double angle formula involving both the sine and cosine functions. Cos 2a is equal to 1 minus sine squared x. So solve for sine x. So we have sine squared x is equal to 1 minus cos 2x over 2. So sine x is equal to positive and negative square root of 1 minus cos 2x over 2. Then, let x is equal to a over 2. So, substitute the value of x. So, we have positive and negative square root of 1 minus cos 2. And substitute the value of x, which is a over 2. Divide by 2. So, simplify. So, we have sine a over 2 is equal to positive and negative square root of 1 minus cos a over 2. Because the 2 is cancelled, so we have 1 minus cos a over 2. For the cosine half angle identity starts with a double angle formula involving only the cosine functions. cos 2x is equal to 2 cos squared x minus 1 and solve for cos squared x. So cos squared x is equal to 1 plus cos 2x over 2. So solve for cos x. So cos x is equal to, so in this equation, we square both sides. So we have positive and negative square root of 1 plus cos 2x over 2. Then let x is equal to a over 2. So substitute the value of x. We have cos a over 2, positive and negative square root of 1 plus cos 2 times a over 2 divided by 2. So simplify. So we have cos a over 2, positive and negative, square root of 1 plus cos a, because the 2 is cancelled. So we have cos a, then copy the denominator, which is 2. So our cos x is equal to square root of 1 plus cos a over 2. The tangent half-angle identity starts with the quotient identity. Tan a over 2 is equal to sin a over 2 divided by cos a over 2. So substitute half-angle identities for the sine and cosine functions. So we have tan a over 2 is equal to positive and negative square root of 1 minus cos a over 2 divided by 1 plus cos a over 2. So simplify. So we have tan a over 2 is equal to positive and negative square root of 1 minus cos a over 1 plus cos a. So half-angle identities, we have sin a over 2 is equal to positive and negative square root of 1 minus cos a over 2. Then our cos a over 2 is equal to positive and negative square root of 1 plus cos a divided by 2. Then our tangent a over 2 is equal to positive and negative square root of 1 minus cos a over 1 plus cos a. Then we have also tan a divided by 2 is equal to sin a over 1 plus cos a. Then tan a over 2 is equal to 1 minus cos a over sin a. For example, finding exact values using half-angle identities. So, number 1, use a half-angle identity to find cos 15 degree. So, the solution is cos 15 degree is equal to cos 30 degrees over 2. So, cos a over 2 is equal to positive and negative square root of 1 plus cos a over 2. So, cos 30 degrees over 2 is equal to positive and negative 1 plus cos 30 degree over 2. Then, cos 30 degrees divided by 2 is equal to 15 degrees is equal to square root of 1 plus square root of 3 over 2 divided by 2.